Okay, so we're going to go through a question on integral calculus, where we're given that in is equals to the integral of the integral of x multiplied by ln of x to the power n dx, and the limits that we are given is 2 from 1 to 2. Okay, so from this that we have here, okay, we have to show that what we have here, okay, we have to show that what we have at this point is equals to what we have here. All right, so that's the first thing that we do, and of course afterwards we'll have to do some evaluating. Okay, so what we have to do here is that we'll have to integrate this, okay, for us to show that what we have here is equals to that. All right, so we know to say we are going to do integration by parts. Okay, so I'm going to say our in, okay, our in will be equals to, so in this case our we are going to choose which one is going to be our u and which one is going to be our v. Okay, I think that's the first thing that we have to write. So our u in this case is going to be ln of x to the power 1. Okay, so ln of x to the power n, I mean. Then our du will be equals to n multiplied by ln of x to the power n minus 1 divided by x. Then our dv will be equals to the x there. Okay, so meaning our v will be equals to x squared over 2. Okay, so you're just integrating the x there, hence you come up with x squared divided by 2. Okay, so we know by integration by parts our in will be equals to u by v. Okay, so that will be x squared multiplied by u, which is ln of x to the power n divided by 2 minus the integral of du by is du by v. Okay, so I have one x on the denominator here, then 1 is going to go there. Okay, so meaning and I think I can write the n over 2 in advance outside, so you say n over 2, this is this n here, and it's the 2 right there. Then the integral of, so here instead of writing x on the denominator and x squared on the numerator, I'll cancel, so I remain with x multiplied by uh, the natural log of x to the power n minus 1, and of course we have dx here, so this will be what, dx. So we're going to say our in will be equals to that will be x squared, okay, x squared multiplied by the natural log of x the power n, okay, divided by 2 minus n over 2. So what we'd like to observe here is that what we have right here, this is similar to the way the function is initially, but the only difference is that just that we are subtracting 1 there. So this is more like writing this as our in minus what, minus 1. Okay, our in minus 1. So what follows, here is that we have to try to uh, we have to try to correct the like terms, but before we do that we have to remember to say we have a limit, and the limit that we have been given is that if I were to do this and that, the limit that we have been given is that we have a 2 as the maximum, then 1 as the minimum. Okay, so where this x we're going to replace with what, with 2, then after that we subtract whatever that we're going to have by replacing where there's x with 1. Okay, but according to the my observation here is that since I only have x here and x here, if I replace with 1 here, that would be what, ln of 1, of which the natural log of 1 is equals to 0, so I don't have to worry about the 1 there, I just have to replace with a 2. Okay, so my in will be equals to, while there is x here, I put 2, that would be 2 squared, that would be 4 divided by 2, that would be a 2. Okay, then open bracket ln of, where there's x you put 2 to the power n minus n over 2, then in minus 1, like that. Okay, So we want to make sure to say this is in the form in which it is desired. So I know to say on this side, I'll have to correct the like terms. I'll have to put the in on one side. So I'm going to say my in, I'm going to add the n over 2 in minus 1, which will be equals to 2, then natural log of 2 to the power n. Okay, so here this and these are the same, but for them to really look the same, but looking at the way it is right now, it means one and the same thing, because here I just have to multiply everything by what, by 2 here. Okay, so I'm going to have 2 in. So I'm multiplying by 2 because of the 2 that I have on the denominator there. I don't want to have fractions in this case. Okay, so I'm going to have 2 in plus um, n in minus 1 is equals to, that would be 4 uh, natural log of 2 to the power uh, to the power to the power n. Hence we have shown, say hence shown. And that's how you go about answering or showing to say what you have here is equals to that part. It's just a matter of using integration by parts of what we have here, and taking note of the limits that we have, which is from 1 to what, 1 to 2. So the question that will follow is that we have to find out what we have to evaluate, because what follows is that we say hence. Okay, hence we have to what, evaluate. We have to evaluate the integral. We have a limit to 1 to 2. The function is x multiplied by ln of x to the power 3 dx. Okay, and remember to say here we had the what, we had n, but in this case we have 3, so we have to evaluate that from what our finding is in this case, but that will be done in the next video. Thank you very much for watching.